Today's lesson comes from section 1-2, what is a function? Take a look. Our learning goals today are quite loaded. Evaluate expressions and formulas, including correct units and answers. Determine whether a relation defined by a table or a simple equation is a function. So we're going to find out what a function is. Determine the domain and range of a function defined by a table, a list of ordered pairs, or a simple equation, and use these functions to solve real-world problems. Now, I do believe we'll probably be spending 2 days on this, so take it all in, take some good notes, hit pause and rewind when needed, but there will be some good vocabulary again emphasized in this section. So let's start with definition of what is a function. Now, it's in the title. Obviously, it's going to be used quite often. It's actually going to be used almost the whole first semester in different ways. And then it's not going to go away. You're going to see it in other courses after Algebra 2 as well. So, a function. Now, a lot of you copied this down, and I would say, why? If you can tell me in words what it means, great. If not, then you should have been, asking questions about this right away. But a function, a relationship between two variables such that each value of the first variable is paired with exactly one value of the second variable. And for some people that can get very confusing. We're talking about two variables and they say one variable, two variables, and paired, and yeah. So we will sort of clear this up as we go forward. Now, one thing we will talk about right now is when they say first variable, second variable, we've usually talked about an ordered pair as x comma y. And we're going to continue to do that. So right now, in the ordered pair x, y, x would be considered the first variable, and y would be considered the second variable. So up on top, a relationship between two variables, so like x, y, such that each value of the first, so each value of x, is paired with exactly one value of the second, or y in this case. So to shorten that up, each x is to be paired with exactly one y. Now, we're also going to give that x another name. It will have several throughout the year. But notice, domain, the set of all possible values of the first variable. We like to think of that as the x values. Then the range is a set of all possible values of the second. We like to consider those the y values. So if we came back up here, we could say, oh, domain range is another way to think of this xy ordered pair. Domain range. Now, a lot of you had a hard time when you first learned x, y's, keep them in order, and hopefully you finally learned that it was alphabetical order. X comes before y in the alphabet, x comes before y in the ordered pair. Do that same thing with domain range, two new words. D comes before R in the alphabet, so domain comes before range in an ordered pair. Domain are the x's, ranges are the y's. So if we were given a graph, this one happens to be a nice horizontal segment. Dots on each end, so it starts and stops at a specific spot. We want to identify the domain and range. And we do have lots and lots and lots of points on this. So think about it first. What kind of numbers? And if you said, and we're going to assume right now, my dots are a little off, but we're going to assume right now everything between the numbers -4 and +6 are currently graphed. So if you said all numbers between -4 and 6, some of you, when you say all numbers between -4 and 6, you just start writing a list. So you do -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and 6. When you do that, though, you should be thinking, well, wait a minute, you said all numbers. What did I list? I listed the easy ones. better known as the whole numbers, the integers. Whole numbers, positive and negative, so the integers, that's all I've listed. Oh, so that won't do. We said we wanted all the numbers. So in this case, if you have a lot more numbers there, you can't just list the whole numbers. We probably need to make what is called an ordered triple to write this. So notice it says all the x values. So I'm going to say x is going to be less than or equal to, because it's a solid dot here, colored in, less than or equal to 6. But also at the same time, x is, reading it inside out, greater than or equal to -4. So really, when we read this, we like to read the x value, the unknown, first, and then inside out. And it really doesn't matter if you go left to right, or left side first, right side first, or right side, left side. But if we wanted to read it again, we will say x is greater than or equal to -4, and x is less than or equal to 6. So all those numbers then are included, all those decimals, all those fractions that we just did are included in that. That would be a good way to write the domain in this example. Now, range on this one's a little different. You start looking at that, you start thinking, well, all the y values, and your eyes go to one spot. There is nothing above this, there is nothing below, nothing up top. There's only one spot where the y values are at, and it's right along the axis. So how do we write all the y values that represent that axis? And there is a value attained to them or attached to them. And so we would write y equals 0. If you think about it, every single point on this line, no matter what you place, where you place your point, the y value for every single one of these is 0. We're not moving up or down at all. We are only moving left or right. So over in here, I would have -3, 0. If I moved here, I'd have 0, 0. Moving maybe here, halfway in between, I'd have 2.5, 0 as my ordered pair. So the way you write domains and ranges will change based on your graph. And there will be quite a few different graphs here. We won't talk about them all during the screencast, but we will save some of them for class so you can get your questions out of the way. So here was just one particular answer where we had multiple x values on our graph, but only one possible y value. Next graph. We now incorporate some of our curves. Some of you like to say, oh, you're graphing a parabola. Okay, but now again, it's not to identify the graph, it's to identify the domain and the range. So start looking for all your x values. So your eyeballs should be going left to right on this graph and saying, what is the lowest x value? What is the highest x value on this graph? As a reminder from geometry, remember parabolas, because of the ending arrows, go on forever and ever. So that pattern that's there must continue. So we're looking at going ever so slightly outward in both directions. It does not ever become totally vertical. So it still will inch outward and get wider and wider and wider slowly as we draw this. So keep that in mind as you do this. So what are our x values? What are our y values? On this one, again, we're going to approximate our graph and take a look at where we're at. If this is ever going to slightly go out, and this one's ever slightly going to go out, I think we're going to have to say all fractions, decimals, because we've included a lot of those right in here where we've been right along this line. Everything that's positive, negative, 0, fractions, decimal would be included. But then if it's going to go ever so slightly out as well, it'll have to go farther than this 6 and this -2 that it appears to be at right now. So again, let's try that triple that we learned last time. X, how do we say all possible x values? How do we say all possible negative x values? In this case, you could write a triple and use infinity. That's what some people like to use because we don't know where it's really going to stop. Others would just say all real numbers on this one. So I could have an x value that includes any real number that we've ever talked about. All fractions, all decimals, integers, positive, negatives, zeros, they all work. Look at the y values. When you look at this graph, the y values, your eyeballs for y values should be starting up here near 40. That's the highest peak. Nothing above there is graph. And then your eyeballs are going down. And the question is, how far? Well, again, these arrows dictate that this graph keeps going. So if my eyeballs are going down and it's like going down forever, what do I write? Will it be a triple? Will it be words like it was up top? I think in this case, we need to say something like y has to be less than or equal to 40. That would then include all the numbers at the top, which we have here, all of them on the way down, and because the arrows move on, we've included that with all of them that are less than or equal to 40. So we do not always have the same type of answer. Here we had a word answer because there were like so many, we couldn't write them. And we had a top limit on our y values, so we had to include the top limit, but then keep it open all the way down to negative infinity. On the last one graph we did, remember, we had the triple. So we only had a certain numbers between here and here. So there's different ways to write your ordered pairs, and it depends upon the graph. They cannot all be written the same way. So I'm just going to show you a couple other graphs, and I want you to think and maybe write out so you're prepared for class. What would the domain and range be for these different style graphs? Difference here, we have a ray, and that ray starts at a certain point, and we can assume that that point is a -1. And then it goes up to the right slightly. So if you would think about, write down what your domain and range is and be ready for discussion during class, that would be good. Here's a next one. Oh, a discrete set of points, random points throughout. How are you going to write the domain and range for a series of discrete points? Yes, these are all possible. So try that one. Here's another ray, but the end of the ray is a little different. It is now open, so be careful how you write that one. And yes, we can assume that ray starts at an x value of -2. New graph here, we have that parabola look, but it opens sideways. So we're saying that it has a limit over here and then continues because of the open ending and the arrows going forever. So here's another one. And now, let's talk about, well, what if it's not a graph? What if it's ordered pairs? State the domain and the range of each function. Once you state a number, you do not have to repeat it. You can, it's not going to make it wrong, but if you want to keep your list of numbers short. So on number 1 that we're looking at here, if I said state the domain and the range of each function, and notice they're saying function, our definition of function was again, each x is paired with exactly one y. If you start looking this, 1 is paired with 2, 4 is paired with 5, 2 is paired with 6, 9 is paired with 0. Each x is paired with exactly one y. So you should be able to go through and state all the x values and then state the y values, the domain and the range. So think of it that way. Then try number 2 as well. And lastly, number 3. And come with questions or differences, similarities that you see that you're sort of wondering about when it comes to domain, range, x's and y's. So those will be good ones for discussion. Then, does the table represent a function? Why or why not? So now that you've practiced writing domain and range, now let's close in on what is that definition of function that we've been trying to dissect. Is there a pairing going on? Yes. Each one is an ordered pair table. Then your definition says such that each x value, each first variable, is paired with exactly one second. Each x is paired with exactly one y. So if you look at these ordered pair tables, and we could call them, choice A, choice B, choice C. It'll be easy to write blind. What would you say your domain is, your range is? Are they functions, yes or no? It should be easy to identify, and again, come to class ready to discuss that and bring any questions that you may have. Now, as we work through functions, there's a lot of repetition when they talk about how they're written. So in this one, I've done some repetition, but I've put in some different names each time to show you how they're interchangeable. So the dependent variable is a function of the independent variable. We've talked about that. We said, usually, y depends on x. Y is your result in your equation, and it depends on what you put in for x. So in this one, the dependent variable is a function of the independent variable. Some of you might think again, put the words in, the dependent variable, or y, is a function of the independent variable, or x. So the y is a function of x, is another way to say that. Knowing that, same sentence, the green, notice, is not changing. The blue's gone, the red's in. We could also say the output is a function of the input. The output on your input-output machines back in elementary was the result, the answer, the y value. And the input was the x. So again, it follows that same pattern. It's just different words you can use for x and y. And there's the one when we substitute them in the easiest. Y is a function of x. They all mean the same thing. We could go and write domain, range, all of those. Now here is, again, 2 more questions stated in this very similar way. If I gave you an ordered pair, M and N, and it's a list of ordered pairs, and then I ask the question, is M a function of N? Yes or no, why or why not? And then, is N a function of M? Yes or no, why or why not? You have to characterize it according to these. It fits them, matches them exactly. But notice I didn't say just because my ordered pair is set up as MN that M was always X and N was Y. So if you're looking at this, make sure you realize it does not say X and Y. It says M and N. So don't stick in your head that those M's in the first slot, therefore it's X, N's in the second slot, therefore it's Y. They are not. It was never stated that way. It was just an ordered pair table. And based on the question, is M a function of N? You already know which one's which by looking back at one of the 3 that you liked from above. All right. With that, we have plenty to talk about in this section, and I think, I think we will be discussing some of that before we continue and assign some homework from this section. So come to class with lots of questions, your new definition of what a function is, lots of vocabulary here. Bring all the questions and the answers from the examples with you.